Hello. Now welcome back to this sixth session on this blinking rays project. Now we have built all the components and animations, we have made it ready. Now we have to apply the game logic. Now in our game, as soon as the user taps, the player is going to run, which is actually we are making the background get animated. Then the colliders are coming. When we blink, the player is going to jump. Now the logic we have to apply here is, when the player successfully jumps over a collider, a point has to be added to him, and if he fails to jump and if he crashes with the collider, the game should get over. So now how will we determine when the player has crashed with the collider or when the player has jumped over the collider? Well, the concept we are going to use here is using the x, y and z coordinates of the collider and the player. Now, when the collider and the player crashes, then their x value will be the same, or it will be within a specific range. And when it is within a specific range, they are both at the same position on the x value, and at that time we have to check its y value. If the y value of the player is more than the collider, it means he has jumped and we have to add the point. And if the y value is not greater than the collider, then it means he has crashed. We have to close the game. So this is the logic that we are going to apply, and for this the first thing we need is, we need the x and y coordinate values of the collider and the x and y coordinates of the player. How are we going to get these values? This is what we are going to do it in this session. Okay, now let us start our work by launching Spark area, that is MetaSpark Studio if it has not been launched, and I will go to file open, and we had saved it as version 5. I will select this version 5 file and I am going to open it. Okay, now the file is open. Now only thing, the very first thing I am going to go do is, I will go to file, choose save as, and this time I am going to save this as version 6. I will save this as version 6 and I am going to save this. Now the next thing we are going to start now is, we have to now get the x and y coordinates. So for this, what we are going to do is, I am going to introduce you to the output variables of a group in MetaSpark. So for this, see now, basically now we are interested with two components now. We are not going to, BG animation has absolutely no role to play in the game logic. So we are not going to use it. This collider animation and player animation are the two things that we are going to use here. Now first I need the collider components, that is the x and y values of the collider. Now for this, I will click on the settings tab here, and here you have one option called group properties. I will click on this group properties, and in group properties you have two fields here. One is the input and another is the output. Now we are going to make use of the output. So for this, I will click on the plus icon over here and the output is created. I will select this output and I am going to call this output as x, and if you want you can write a description. This is the x coordinate of the collider, and this type is, this is a number, and input limit, there is no input limit, leave the default value as it is, and then I will again click on plus again to add one more output, and I will name the second output now as y, and I am going to type this as y coordinate of the collider, and then we have two values, output values we have added over here, and with this I will click on the collider animation, and now you can see here you have two outputs coming out of our collider. One is its x value, the another is the y value. However, you cannot just directly use it. You have to procure this value inside this group. So, for that I will click on this diagonal arrow mark over here to open collider animation. I will maximize the screen, and in collider animation if you come, now you can see this x and y tabs are added here. See, we have this x and y tab added, and now I need the x and y coordinate of this collider. In collider you have three values, x, y and z. Okay, and I want this, say for example I come over here, I will choose simulate touch, and when I play the game you can see these values continuously changing. So, I want to continuously get this x value from this. So, for this what I am going to do is I will stop the game. Now, I will come in this transition, and this transition is giving us the x, y and z values of the collider. I will drag here, and I am going to now add a patch. The patch that I am going to now add is called as unpack. Unpack is a readily available component in Metaspark. I will select this and I will click add patch. Now, what happens is when I add this patch, you can see this patch takes the vector 3 input and it is going to separate x, y and z values. And now what I will do is I will take this x value and link it to x here, and I will take the y value and link it to y here. Okay, this is done. Now I will come back to main, and now you can see in our collider we have x and y values, and I can use this value for my game logic. Now the same thing I am going to do it even with the player animation. Now with the player animation, I am going to select the player. I am going to now click on this settings, go to group properties, and again here in output I will add one output, select this output and name it as x. This is the x coordinate of the player. Okay, and I will add one more output. I will call the second one as y, and I am going to call it as y coordinate of the player. Later after this, keep the type to number, and now if I click outside, again here also I have two outputs x and y. I will again open this player animation, and now in this player animation also you have this x and y values. Now even here I will take the output from this transition, I will drag it, the add patch window automatically opens. I will select unpack, and selecting unpack I will click add patch, and after I add this patch I am now going to connect x over here to the x and y to the y here. So now we have unpacked the vector and we are getting out the x and y values of our player. Now I will come back here. Now see, we have x and y of the collider and x and y of the player coming out. Now the next thing I want is I want to test their condition, that is I want to do some testing of the condition. So now testing of the condition means the very first condition that we are going to test is the x value of the collider and the player is the same. So now for example, if I play the game here, I will come to player and to this collider animation. I will open it, and here in the duration, in this loop animation, I will just drag this input and place it correctly here. In this, I will change the duration to 5 so that it moves slowly now. Okay, I will come back to main, and now if I tap it, see the collider is coming slow. As it comes close, I will stop. Okay, now see what is happening is, if I open the collider animation, and now you can see what is the x value. It is minus 108 is the x value of the collider. Now I will go back, and if I open the player animation, here the x value is minus 125, means the x value of this and this should be equal with the difference of around, I will keep approximately 50. Okay. So now what I am now going to do is, I am going to come back to main, and I am going to control compare the x value of the collider with the x value of the player. So for this, I will click on add patch, and here I will add a node called as equals to. See, you who have this equals component, I will click on add patch. Now in equals, the first number I am going to give this equals is the x value of the collider, and the second number I am giving is the x value of the player. Okay, and I will set a tolerance here. It need not be exactly equal, because see, these two are an object each of a size of about 100 by 100. Okay, this is a photograph of about 100 by 100 size. So the thing is that the tolerance I will set it so that even if the player touches just the edge, see, I will play it and show it to you. Even if the player touches here, it means he has crashed. Okay, so I have to set this tolerance. So I will set this tolerance to approximately 50. So now when the collider animation and the player animation, when they actually crash with each other, I want something to show me as a symbol. So just like in the last case, what I am now going to do is, I will go into face tracker, and I will close all these elements here, and I am now I will go to face tracker, right click, add object, and I am going to first create a canvas, and I am going to call this canvas as the test. This is for testing we are using. Later on we can delete it, and in this test, now I am going to add an object plane. I will add one plane here, and this plane, for this purpose I will make the plane a small plane. So I let its size be 300 by 300 by 300. So I make a small plane here, and for this plane I will add a material, new material, and if you come to the asset, I will name this as test. What is going to test? It is going to test whether it has hit. And even here in test, for this plane 0, I will name it as test underscore hit. And here in material, I will just add mat underscore test underscore hit. Okay, I will select this mat underscore test underscore hit, and in color I am just going to give it a red color. I will choose a red color, and then I will set its shading to flat. Okay, now I will take the move tool, I will select this test hit, and I will just drag it and keep it somewhere here, so that it just tells me whether the collusion has happened or not. And for this test hit, now I am going to click on this visible tab. It will add the test hit here, and then I will connect this equals to this test hit. Okay, so now see, initially now, since it is not hitting, since x and y are not equal, you are not seeing that red icon, But when I play, as soon as the obstacle comes, see the red appeared and it goes away. You can see whenever he touches the red, see you can just check whether your tolerance is fine by playing this. See, as soon as it touches, the red should start. So now this crash, it is detecting it correctly. So as soon as it comes, the crash is happening. Now the next thing we want is, if he jumps, say for example I will blink and I will make him jump. If I blink and if I make him cross that, then I want a green to come here. As soon as it comes, I will blink. So if I blink and if I cross it, then I want a green to appear there. So now this part, let us do it in our next session. So right now I will stop the game playback. I will stop it. Now I will come here and I will reset the game, then go to file and choose save. So in this session we have detected the collusion between the player and this collider. When he avoids the collider, how to track it, that we are going to do it in our next session. Thank you.